What's going on, guys? Johnny Bannon here at Trepa Technologies, and today we're going to be going over domain 1.3 of our Network Plus course. So let's go ahead and take a look at the exam objectives here. I'm going to flip up my screen, and we're going over domain 1.3. So I'm kind of going backwards here. The first thing I'm going to go over is actually these sections here: deployment models, service models. I just thought it was a little weird that we'd get these, like, I wouldn't call them advanced features, but features that are like exclusive to virtualization and cloud technologies without hitting some of the fundamentals over here. So I'm going to go over these topics first, and then we'll talk about these more specific features, technologies within the cloud, right? It just wouldn't have, like, to me, made a lot of sense to start with network function virtualization and then at the end talk about the different service models in the cloud. So that being said, let's go ahead and get started. I am going to zoom out here on my face, and I'm going to go back to our slides. All right. So again, here we have our objectives, and as you can see, I labeled them in my PowerPoint with how we're going to start. So the first thing we're going to go over is deployment models. So before we actually even talk about the cloud, now I'm trying to keep this brief because, again, I could talk about the cloud for hours. I want to go over three fundamentals with you guys. So I'm going to bring up my Zoom whiteboard here and go over those fundamentals first. So the three fundamentals of computing, or computer technologies, computer networking, and then a fourth kind of additional fundamentals that I think applies to the cloud. So what I'm talking about here is network, compute, and storage resources in computing. When we talk about these three basic fundamentals, we can bring up data centers and how they're built off storage, compute, and network resources, and how our data centers kind of became cloud technologies where, we were able to spin up resources on demand, scale elastically with high scalability. And when I say on demand, meaning that the cloud is just a console, a portal that lets you deploy, manage resources in a cloud data center, right? That's public. The base model of cloud was first public, right? But every data center, whether it's the cloud, whether it's on-prem, whether it's in your little comms closet, has these three basic resources: storage, compute, and network resources. So if I were to draw like a data center rack here, maybe at the bottom we'd have power, right? So that's something that's also basic in IT and technology in general. We need power. So at the bottom here would maybe be like a power distribution unit. Maybe that'd be up top, an UPS, right? And if this was a on-prem data center, this would be maybe a generator. We'd have multiple lines coming in from the grid. This would be zoned correctly. We'd have a generator as a backup doing ATS, automatic transfer switching. And then each rack would probably have its own UPS that was rated for whatever wattage we were getting to last 30, an hour, 2 hours, just depending on how much we care about power redundancy. So down here we'd have like an UPS, an uninterruptible power supply. It's a big battery backup, okay? And then next, I like to use green for this. We'd have our storage. So this could be like a storage area network solution. So I've worked with NetApp, so that's always what I draw. So we could have two NetApp controllers here with, hundreds of terabytes of storage, a bunch of blades in here, or, drives. So it kind of looks something like this. That's our SAN storage, okay? So this would be our storage. And then most of the time we have a data center. This is a basic build. We want to run applications, right? We want to run services, domain controllers, Active Directory, DNS, functions for our enterprise. We'd have this storage here that could be our file shares for our users, but this could also be like the VMX files for your virtual machines that'll host all those apps and services. So we have this storage unit, right? And then we would have our compute. Now, again, I just coming from experience, I worked with Dell PowerEdge and Cisco UCS chassis for the compute. So our compute would be all the RAM, the memory and CPU and sometimes GPU, right? Talk about AI for data centers for AI, NVIDIA, right? GPU. This would be our compute. And this would be our RAM, our CPU, and our GPU. And then to tie it all together so all this can talk, we'd have our network. So I'm going to draw like a distro switch here. And maybe this is like a Nexus switch. Again, Cisco background, so Nexus, right? This would be our network. So these three main resources. Yes, I drew them in a data center rack, but they're the three main resources on your computer. You have a NIC, you have CPU and RAM, and you have a 1 terabyte or a 500 gigabyte solid state or NVMe drive that hosts your operating system. In a data center, we have these same resources. And when we move all this and talk about all this in the cloud, right? So I'm going to draw my cloud here. This is my CSP, my cloud service provider. The cloud provides the exact same thing that this old-fashioned data center rack provides. Storage, compute, and network resources. Okay, so now that we know the fundamentals, why am I teaching you this? Because when we start talking about the public cloud or private cloud, and I show you a cloud console, I want you to understand the purpose. The cloud was meant to do something called operational expense versus capital expense. Because all this right here would be upfront. We'd have to pay for the hardware. We have to pay for licensing from the vendor, whatever we're using. There's going to be an end-of-life, end-of-sale life cycle we have to worry about. We're going to have people that are skilled probably in like a storage administrator, a server system administrator, and a network administrator just for one rack, right? Obviously, some companies, make some people do it all. But with the cloud, you can have a cloud engineer that, that could do all this in the cloud. So when we talk about public, the service models, just know that the purpose is to provide this. And you may say, well, what is this? I get it, network, compute, and storage. But what we're really talking about here is our apps. What applications we're providing, okay? What applications we're providing to the enterprise. Now, I said I'm going to talk about a fourth thing. In the cloud, kind of that fourth fundamental we have to worry about, because it's kind of like the base of everything. Anytime we spin up a resource, we're going to have to worry about identity access management, IAM. So it's kind of almost like the fourth fundamental. When I teach my cloud courses like Azure or Cloud Plus, I always bring that in there like, hey, every resource you deploy in the cloud, whether I'm spinning up a Kubernetes instance, containers, web service apps in Microsoft Azure, a VM, a storage resource in Azure, a storage bucket in Google Cloud, there's always a service account or some sort of account assigned to that resource, right? So IAM, identity access management, is another important thing within the cloud. Now, with that being said, let's go back to our slides and let's talk about the different deployment models. So we know, we get it. Okay, Johnny, we get it. We understand the purpose of the cloud. But now let's get into it. So what are we first going to talk about? The different deployment models available to us. So public. The public cloud is going to be what every individual business is first going to access, okay? This is a multi-tenant, pay-as-you-go solution that gives you access to a portal to deploy resources in a public environment. Meaning that if I place a VM in the US East Region Zone 1 Alpha in Google Cloud, and you deploy a VM, it's possible that we could be sharing the pool of resources, our compute and storage and network resources, to host the service I'm running on that VM. So this is accessible over the internet. It's going to be managed by the cloud service provider. What we mean by that, kind of getting into what's called the customer responsibility. The customer responsibility versus the CSP's responsibility model. So we call it like a trust model or a responsibility model matrix. The public cloud, you access via a portal from anywhere that has internet. It's a pay-as-you-go model, operational expense. You can easily scale it, and you can deploy resources that get pooled with technically other companies' resources that they're essentially almost renting from the cloud. Now, the actual cloud data center is going to be maintained by the cloud service provider. The uptime Now the physical uptime, that's not me misconfiguring something on the VM. That's my responsibility, right? If I deploy VM in the cloud. The uptime, the power, the physical security, the security of the console. Not necessarily your credentials to access the console, but the console, the control plane itself, that's maintained by the cloud service provider. And we'll talk about more of this relationship here between the customer responsibility and the cloud service provider responsibility when we get into service models. Now, I'm probably going to stick to the slide decks right after I show you guys what a cloud portal looks like. So I'm going to show you what a GCP, a Google Cloud Console, looks like, and also what the Azure portal looks like. So if we scroll up here. So this is the Google Cloud Console. You can see here if I want to deploy some VMs, I can come here and create a new VM. This is me interacting with the cloud. This is what I like to call ClickOps, where we're not automating, I'm not using Terraform or any other automation tools to spin up resources and manage them. This is the Azure portal. It also has virtual machines. It also has all these different resources we can deploy. Virtual networks, storage accounts, Entra ID, which is the identity access management for Azure. I just noticed the screen's cut off a little bit here, but we can see here, create a resource here. Yeah, sorry it's cut off a little bit. Let me do this for you. There we go. And that's the Azure. So you can see, if we come back to the Google Cloud, it's a little bit easier to look what's available for us. The network resource, a storage resource, a compute resource, and IAM. So I love talking about those four fundamentals and showing the Google Cloud, because it's like, yeah, look, this is it. This is what we're providing for you, right? Okay, let's go back to our slides now. Okay, private. So a private cloud is a cloud infrastructure operated solely for a single organization. So this could be like GovCloud, where, we're using a secret environment, mandatory access control saying, hey, you got to have a secret or top secret clearance. And this is your GovCloud instance that's solely for you. So you're not doing multi-tenant pooled resources. We're giving you a console, access to a cloud console that's private for you to directly interact and access with and deploy resources for your enterprise. Or private cloud could be your own data center that you decide to make highly available. And what we mean by that is, like, if I deploy E6i and I make it publicly available for anyone to access and spin up resources on their own, it's kind of like a private cloud, right? If I let users or the IT team that may not be part of my data center or system admin team spin up resources in our data center, that's considered a private cloud, right? So private cloud, if you're going through a CSP, it's cost, right? It may not scale as well because you don't have access to the entire cloud data center. You're sectioned off in your own physical hardware. But you can customize better. There's a private cloud that's sitting on-prem you can customize. Then hybrid. So the hybrid deployment model combines any of them. Combines a community cloud, which wasn't on the exam objectives, so we're not going to talk about it. But it's a combination of either on-prem and cloud resources working together, kind of like pushing Active Directory up to Entra ID, right? That's a hybrid model. It's combining private and public. It's combining community and public. Any combination of the models to include on-prem, right? Because you can hybrid solution public resources and on-prem solutions. So flexibility, some more cost efficiency with the hybrid, and you get a little bit more control if you're like, well, I want to use the private cloud with public cloud, and I get a little bit of control over these resources that maybe fall under some sort of compliance issues that we may have, right? All right, so now let's go over the different service models. So the first service model we're going to talk about is infrastructure as service. Now this kind of gets into what I was talking about earlier with that customer responsibility versus the CSP's responsibility. So I'm actually going to come back to our whiteboard here to discuss this, then we'll come back to the slides and make sure I didn't miss anything. So let me give us some room here. So we're going to go over the different service models. All right. And we're going to be going over what's called the customer responsibility versus the cloud service provider's responsibility. So what we're talking about here is the different service models in ways we get more control of the resources we deploy, okay? So let's talk this out. So let's go over on-prem first. So if my goal, right, because we're thinking about business objectives, what's our goal here? I want to deploy a e-commerce server, a web app, and I want to do it the old-fashioned way where we build it custom and it's real crazy. We don't just use Shopify or something like that. E-commerce. We can even get more realistic. I want to host a customer management system, okay? So let's say we want to do this completely on-prem. So a capital expense. We're buying the hardware. We're buying the technicians. We're going with the vendors with our very authorized resellers. And we're building it out ourselves. So with on-prem, we have total control and everything's our responsibility. So with on-prem, power is going to be our responsibility. And what I'm going to do here actually, guys, to make this cleaner, I'm going to make this blue. So when you see I write something in blue, that's the cloud service provider's responsibility. So everything on-prem is obviously going to be the customer responsibility in black, okay? So the power is going to be our responsibility. The power for all those resources. The HVAC, or environmental, is a better way to say it, but HVAC is going to be our responsibility. The storage is going to be our responsibility. So I'm going to say just hardware first, okay? The hardware is going to be our responsibility. Updating the firmware is going to be our responsibility. The middleware is going to be our responsibility, okay? The actual operating system is going to be our responsibility. The applications we deploy and run is going to be our responsibility. The identity access management, the physical security is all going to be our responsibility. And then, of course, we'll draw this out like this so it'll give me some space. The storage resources, whatever that may be, our responsibility. The compute resources is going to be our responsibility. And, of course, the network as well. So on-prem, you can see we got to do everything. We got to manage everything. Our security is up to us. The power, the HR, everything. Now let's go over infrastructure as a service. So if infrastructure as a service, this is us renting or using the cloud, right, for deploying applications. So what is the cloud responsible for here? They're going to be responsible for powering their cloud data centers. They're going to be responsible for the HVAC. They're going to be responsible for the hardware. So that's going to be the rows and rows, the petabytes and petabytes of storage and compute resources. The firmware is going to be the CSP's responsibility. Now we get into the customer responsibility. So if infrastructure as a service, essentially what we're doing is almost like renting a server from them. Now it's actually not renting a server. You don't get full access to like a bare metal, but essentially we have to provide everything. The cloud service provider is going to say, hey, you want to do infrastructure as a service model? We're going to provide the hardware that's going to give you the storage, compute, and networking resources. But you're providing everything else. It's going to be your responsibility to make sure it's secure, that the right role-based access controls on there, or the right identity access management on there. You're going to be worried about the patches, the updates for that application, for that OS, everything. So what's our responsibility now as a customer? The middleware. The operating system. And with that, the patches. The updates, which I know we're a little redundant there, okay? The actual application that we're developing and deploying, we're responsible for. The actual IAM, we're responsible for. So what do we mean by that? Well, when we talk about identity access management, that means, we're responsible for securing the access to that resource via the console, or what the actual users are going to access, okay? Now, when it comes to managing storage, compute, and network resources in the control plane, that's also on us, okay? So the storage. And this is like the resources we're configuring, right? Compute and network. That's on us. One thing I forgot to add here is the physical security is on the CSP, okay? So I'm going to add that here. Physical security. Okay, next. The next service we're going to talk about, or service model, is platform as a service. Now, platform as a service, the CSP is going to have a little bit more responsibility here. Because with platform as a service, what we're using a platform for is to easily develop on top of. So sometimes we have an organization that develops like a learning management system like myself, like Trepa Technologies, and we just want to deploy our code. We just want to deploy it to an application, maybe get some additional features like the ability to have high availability, CDN, stuff like that. But we don't want to manage an operating system. We don't want to patch the underlying OS and worry about updates and security like that. Maybe we just want to code and deploy our code to that platform and develop on top of that platform. There's a lot of services like this beyond just the big three of GCP, Azure, and AWS. Things like Vercel, Heroku app that are just specifically platform as a service that developers use to deploy their apps, right? So platform as a service, I'm going to speed this up a little bit. Same things, power, HVAC, because the platform we're building on top of, still underneath that is a server, an operating system, right? The hardware, the firmware, and now, additionally, the middleware is the cloud servers' responsibility, service providers. The actual OS and the patching and the updates for the underlying OS is the cloud service provider's responsibility. Now, this is a little tricky with IAM. It's still our responsibility. Like when we deploy an app and we sign into like a console for a Heroku app or Vercel, it's still our identity we got to protect, right? So it's still on us. It's still on us. And then the application. Now we talk about storage, compute, and network. That still can be on us because the platform as a service, even though we're not maintaining our own OS, we can still select if we want to scale up, right? Like, hey, we need more CPU. Hey, we need more storage for our database. We just had to do that ourselves. We had to migrate from off Heroku app to Vercel. My developer told me all about it. Pretty much our app got too big, right? To make a long story short. So that's something we had to control, right? Okay. And the last thing we're going to talk about is software as a service. So software as a service, really the CSP is responsible for everything. The only thing you're going to be responsible for as a customer, besides just payment, right, is still IAM. So think of this like Google Suite. So think of this like, hey, we use Google Suite because we're a small startup. I don't need like Microsoft Office 365 and all that, or Active Directory or nothing like that. So I use Google Suite of tools. So that pretty much just gives me an admin dashboard that lets me make new users with the trepatech.com domain. And that's all my responsibility is. To make sure my IAM and security is still good, enabling two-factor on all my users, resetting passwords, setting users to have 500 terabytes or 1,000 terabytes of Google Drive storage, and that's it. Everything else, Google has to make sure it's up and running. It provides me the console. It makes sure that it's highly available. It does updates to the application itself. I'm not developing anything or controlling anything besides just the features that I'm essentially renting from them, right? So with software as a service, power, HVAC, hardware, I'm going to start abbreviating, firmware, the OS, the middleware, the actual application, the services that you're renting, right, to make sure that they work, is all on the cloud service provider, okay? Let me fix this handwriting because I want to make this whiteboard available after, like, for each domain. So let's see. Services. That's all on the cloud service provider. What I'm responsible for is going to be like that identity access management. All right, awesome. I'm looking at the time. I want to keep these videos a little shorter, but let's just go ahead and knock these slides out now. So again, infrastructure as a service. The cloud service provider hosts the infrastructure components. Platform as a service includes provisioning of servers, storage, network operating resources, middleware, database management. Software as a service, this is applications that you're going to like essentially rent from that cloud service provider. Okay, another cloud concept you want to go over, scalability. So scalability is how easily we can grow our resources or expand our resources. So we're going to go over two different scalability types. We have vertical scalability, which is takes a single node and says, hey, this node, you're really robust. You have way more compute and storage resources than we'll ever need. So we're only going to set you up at a small amount. And then if we need it, if we see a large influx of users, peak hours, we're going to scale you up, you single node. This is very simple because it's only one node you may have to manage, a single VM, but it does limit because as we're going to learn with horizontal scalability, you can't pull resources. Vertical scalability is just, I'm going to buy a big, robust, meaty server and I'm going to scale it up and down as I need, okay? But once I hit that upper threshold of what that server has, the capital expense, right? What it has, then, that's it. Now in the cloud, that also, I'm kind of talking like I have a server right here chilling, right? That's also true in the cloud. With horizontal scalability, this involves adding more machines, pooling resources, making that kind of distributed system to increase capacity. So it's a core principle of modern distributed systems supporting growth by clustering and adding more instances, adding containers, right? Clustering containers maybe is a good way to look at horizontal scalability. Maybe you're deploying ESXi and you have 8 ESXi hosts that you cluster together and you pool resources together. It allows for near linear scaling where adding more nodes closely matches the increase in capacity, but it does increase complexity. Think about if we're using something like K8s or Kubernetes to cluster our containers, to pool together resources, to have hyper scalability, right? A little bit more complex than just going to a VM and saying right click, settings, 32 cores or 32 gigs of RAM, right? So elasticity is the ability of a cloud environment to automatically scale resources up and down in response to changes in demand. So what we're saying here, like you may say, what's the difference between this and scalability? Scalability is just like are we capable of it? Are we capable of scaling up or down? And what kind of scaling do we have? But elasticity is this. It's right of bang, right? Incident happens. We have high demand, increase, right? How elastic are we as an organization with our resources? And are we doing it the right way? Where with low demand, we scale back down because the cloud is operational expense, right? So we don't want to have that increased monthly bill if the high demand was only for a peak day, right? Maybe we had a flash sale or something on our e-commerce. So elasticity ensures that organizations only pay for the resources they need at any given time. It's a cost optimization scheme. Multi-tenancy. This is a cloud architecture where customers and tenants share the same physical infrastructure, but have logically isolated environments. So what we talking about multi-tenancy, that's just the cloud, right? It's just the public cloud where we say, hey, we have this cloud data center. We have multiple racks. And when you deploy a VM, company A and company B deploys a VM, guess what? You can live on the same server. Multi-tenant environment. All right, now let's do our quiz and finish up this section. Okay, so we're going to be doing our domain 1.3.1 quiz. So question 1. Which of the following is an advantage of using software as a service over traditional software deployment? So I'm going to go with C. The software is accessed over the internet, eliminating the need for local installations. Just easy, right? We don't have to create our own Google Suite if we could just pay for Google Suite, right? Question 2. Which of the following best describes the concept of elasticity in cloud computing? I'm going to go with B. The capability to automatically scale resources up and down based on demand. And I believe that's going to be the right answer. And remember, this is cost optimization. We know that we can scale in the cloud. That's the whole point. But how? We want to be elastic. We want to be flexible. We want to make sure that we only are scaling up or down based on demand. Question 3. What is the primary benefit of multi-tenancy in a cloud environment? I'm going to go with cost savings. Because this is a public cloud deployment, it costs way less than the private cloud. I hope I did mention that in the slides. Then question 4. In a private cloud deployment model, who is typically responsible for managing the infrastructure? All right, so this one's a little tricky, right? So I want to say that, and let me just bring this up real quick. I want to say that for this question, it's going to be C. Now, with the private cloud, like I've talked about, in the private cloud, it could still be a CSP. Like the Gov Cloud still is the cloud service provider, right? But a private cloud could also just be the actual organization. So I'm going to go with C because I think what it's trying to tell us here is that a private cloud can be your own on-prem data center that you make to behave like a cloud environment. And even in the Gov Cloud, yeah, typically you're managing a lot of your own resources. But we're going to go with C, right? The CompTIA exam. All right. Question 5. Which of the following cloud deployment models allows an organization to leverage both public and private cloud resources? Hybrid, right? The mix of both. Question 6. Which of the following is a characteristic of infrastructure as a service? Not A, not B. I'm going to go with D. Virtual machines, right? With a virtual machine, you own it. You own the operating system. And that is infrastructure as a service. All right, everyone. I want to thank you all for viewing. Don't forget to like and subscribe. And stay tuned for our next videos. Hopefully, we're going to have this Network Plus course done pretty soon. And we look forward to completing this course. Don't forget to like and subscribe. Have a good one.